Hey, this is Don from Padlock Technologies again with another video. This time is the long-awaited MPLS SRTE with SDN lab that I promised a long time ago. If you don't know what MPLS SR is, I'm gonna put a card in in this video up here, somewhere up at the top or on the side somewhere, that gives you a brief overview of what MPLS SR is. Now, this is a very phenomenal technique that I've learned, especially with the SDN piece, because what we're going to do is this is going to be SR traffic engineering, and we're going to decouple the control plane from on the PE, which is going to be called the PCC, to the PCE, which is the path computation element. What basically is going to happen is we're going to push all our routing information from each domain to this component called the PCE, and then that's going to make the calculations, and then that's going to actually put the labeling in the path for you. So basically, you're going to see on-demand tunneling as well, which is another technique that you can do with SRTE. But let's go ahead and go in the lab. It's already kind of pre-configured, so I'm just going to go over it, and then I'm going to show you some of the components here. So here we are at the lab. Now, I'm going to just tell you flat out, a lot of this stuff is not turned on because my lab server started screaming at me when I turned everything on. So what we're really going to focus on is this CE here, which is XR1, and then this CE over here, where it's SR6. Everything else is in the middle. It's pretty much the same, but everything else is turned off. Now, it's already configured. If I turned it on, it would just be working. But because my server was screaming at me, I decided to turn all that off. So here are the components. We got 3 domains. We have ISIS domain 50, ISIS domain 51, ISIS domain 52. The CEs on this side technically don't know anything about the CEs on the other side. Sort of like unified MPLS, but a little different. Now, we have these 4 controllers here, which is router 9, 29, 30, and 39, which is 30 and 39 are technically off. They are technically my PCEs. So basically what that's going to do, it's going to know all the information from instance 50, instance 51, instance 52, and it's going to be able to do the calculations for the CEs to get to each other, since they don't really technically know about each other. Now, there is a caveat to this design. On the CEs, let me pull up a CEs, to get to the other CE is actually a null route. Now, the reason why we put the null route in there is because if you know anything about BGP, you need to at least be able to get to the next hop. If the next hop is not in the routing table, or you don't know how to get there, it won't even do anything from a BGP best path selection. So you kind of fake it like you know where the route is, but it's technically going into a null route, which is a black hole. So let's log in here so we can verify that here. If I do show router static, here's all these null routes here. So 6, 10, 19, which is the CEs on the other side, or PEs on the other side, all good to null 0. All right. So we're also doing, BGP link state, which is a AFI, sub AFI. And that is to push all that information to the PCE so it can make its calculations, right? Sort of like what you saw in optimal route reflection. I got a video on that. Just type in optimal route reflection and that'll come up. Then we're just doing your normal VPN, V4, MPLS, L3 VPN stuff. So that's the typical stuff. The real difference here is the calculations going to be based on automated tunnels that will be created based on a color. Now, this is only done on iOS XRs. I haven't seen an iOS XE. You can still do segment routing with iOS XE, but some of the advanced features like SRTE with on-demand tunneling and PCE to PCC stuff, some of that stuff you can't. There's some components that don't work with just iOS XE. So we had to use ISXR to get this to work. Now, the other part is, do not try to do this if you don't know the basics of IGPs, basically OSPF, or ISIS. You can't really do this with EIGRP because you need link state information. You need to know how BGP works. You need to know how SR works. You need to know how MPLS works, because there's a lot of moving parts. And when I go through all of this, you're going to see all the moving parts here. So the main thing that we need to worry about here, there is some redistribution here on router 4, 5, 7, and 8. So you need that redistribution just to get reachability between the PCC/PEs and the PCE/route reflectors, PCC/PEs. Since they're in different domains, that's the only thing you're redistributing. So from ISI's domain 51, I'm only doing the route reflector loopbacks. And from the other two instances, it's only the PEs. All right. So if we go into router 4, now I'm going to show you a couple routers here because they're pretty much the same. So if we look at, let's look at the instances here. We're going to do router ISIS 51. So you can see how it's set up. Now, remember I was telling you that in iOS XR, everything is under the global configurations compared to iOS XE or iOS, where you kind of do things at the interface level and the global level. Well, as you can see, for routers, any kind of routing configuration, you pretty much do everything from an IGP's perspective under the routing process. All right, so we have our typical level 2. It's easier to go from a level 2 to level 1 for things you want to do than a level 1 and level 2. From a design aspect, you really need to go level 2 for everything, and then if you want to change things to level 1, it's a lot easier. We have our net. This is for Area 51. Now this is the only thing you can do. You technically do this in iOS XE too, but we're going to use an instance ID so that the link state information is per instance. So you're going to see this for instance our router ISIS 51 and the other one for router ISIS 50, right? For router 4, and then on router 5, it'll be 51 and 52. Metric style wide, that is to get segment routing to work. Now, this is where you enable the traffic engineering because you need to enable traffic engineering to actually do MPLS SRTE. And then here's the redistribution that we're using the route policy to go from 50 to 51 where we're in instance 51. So we're redistributing from 50 in the area 51, and then you have to activate MPLS, segment routing MPLS. Next thing is these prefix SIDs. This is just the prefix SID for loopback 0, but the real specific one here is loopback 1 has the end flag clear. So this is called Anycast SID, right? Because they're using the same loopback address. And when you want to do load balancing between 4 and 7, if it should pick that Anycast SID, that means I can either go to 4 or I can go to 7. So that's what that end flag is being cleared off of compared to the loopback where the end flag is not cleared. So if we look at the ISIS database, you will see end flag 1, right? So it means it's on. And then for the one that's end flag clear, to be 0. And then obviously we're putting everything, point to point and just putting, the interfaces into the ISIS domain. So if I showed you 50, pretty much the same thing, right? But the redistribution is coming from 51 to 50. And I'm going to show you what the route policies look like. Remember, there is no route maps in iOS XR. It's all route policy. So we'll do 5150. And this is where knowing a little bit of Python kind of will help you. Because if you look at this, this is basically a conditional statement that says if the destination is in the prefix list 5150, then let it through. And then end if, right? This is why I said this is RPL. So if you really want to know RPL, then you need to know conditional statements in Python, because that's basically what it is. If this is this, if this, do this, else if this, and if else that. You need to know all of that if you really want to get proficient with RPL. That's basically what everything looks like. Now from the MPLS forwarding table, here's the MPLS forwarding table. We have a lot of adjacency SIDs, and then we have our prefix SIDs here. So what you can see is this 1690 or 16098 is actually on the other side. That's between router 5 and router 8. So that's technically the Anycast SID in that domain. And that Anycast SID is in 50 and in 51. And then on the other side, it's in 52 and 51. So router 5's Anycast SID is in 52 and 51. And then router 4 and 7's is the same thing, 51 and then in 50. So we got that going on there. So now that we got the redistribution from a PE standpoint, if we look at our normal Let's see what our adjacencies here for BGP is. So we got VPN v4 unicast summary. As you can see, we got it right now. You see these are idle. That's because I turned them off. So we're not going to see anything there. But we do have a prefix coming from 29 and 9 and 29. So we have that there. Now, if we do show BGP link state summary, we got a whole bunch of stuff. So now see, as we can see here, since we're route reflector clients of these two, these are all route reflectors here. We got 140 things going up in here, right? And that's basically the information in for every link carried in BGP. And I did a link state video, I believe. But if we want to actually see what that link state information is, here it is. So here's all the layer 2 stuff, which is the V's. Then we have more information here with the E's, which is more information per link. Keep going, keep going. This is within the entire domain here. So then we got the T's here, all right? Which is just more information. So all of this information, 140 links worth of information, is going to the route reflectors. So this is how it's going to make its calculation on how to get to certain areas or what labels to put on the service label. Because what's going to end up happening is once the PCE is going to look at the entire topology from all the domains, and then it's going to stack the labels on top of the service label. So it will go through and labels will get stripped off, swapped, and all that good stuff, and then get to the end. But the calculation is based on the PCE and not the PE. Now, how does that work? Well, there's a protocol called PCEP, right? And I know I'm saying all these acronyms, but once you see the flow, once you start studying this type of stuff, you'll know what I'm saying. But the PCEP is the protocol between the PCC and the PCE. And what that does is basically you are now allowed to say, hey, when I want to go to a certain color, because that's how policies are in route and segment routing, which I didn't show you in the last segment routing. That was just basic vanilla segment routing. This is TE. So now you have to create policies, sort of like MPLS TE, where you create tunnels and you create policies, explicit names and stuff like that. Or you can do dynamic. But in SRTE, you create a traffic engineering policy. Now you could do a static policy where you pick the labels or you pick the nodes that you want to send it to, or you can do this thing called an on-demand tunnel and say, okay, on-demand dynamic, and then PCEP is the option you want to select. And that says, hey, find this automatic tunnel for this color, find me a path. So what does that look like? So if we go show run segment routing, we're going to see it here. So I'm going to talk about all this. So this PCE is the configuration on the PE side to say, hey, here's the path computation elements that I can reach out to compute me a path for this dynamic tunnel forever or whatever I want. Right now, it's all based on the lower preference is more preferred. So 0 is obviously going to be more preferred. Now, if 9 goes down, it'll go to 29, keep going down, right? Now, here's the actual policy itself. So this is an on-demand tunnel. The color is 200, right? And this is the color is an extended community for the route, and I'll show you what that looks like. And what you're saying is find me a dynamic path. And I'm going to use the protocol PCEP. So I'm going to reach out to the PCE to tell me how to get there. So if it's a dynamic tunnel, what is this color thing? Well, again, this is only in XR, iOS XR, is this extended community opaque. Is that what they call it? Opaque. It's a list, right? So it's a extended community opaque list, right? So if I show you what that looks like, is show run X community. Hopefully, X community set. That's what it's called. X community sets. I think I called it color 200. X community set. What is this? What did I call it? Oh yeah, opaque. There we go. Opaque color. You gotta sometimes forget those keywords I put in. So all this says is the color that I'm going to attach in a route policy is the color is 200. It's just a numerical value. Now we're going to use an export route policy command under the VRF, and this is going to be additive to the extended community. If you don't put the additive keyword, it's just like a community list without the additive keyword. It will just replace whatever the community value is set on the route, and you don't want to do that. You just want to add it to it, right? So we look at our route policy here, and I believe I made the route policy the same name because I like to keep things in order here. So here we go. We're going to set the X community color to color 200, which is just the value of 200, and we're going to add it to the extended community. Now, where does this apply? This applies at the VRF level. So under the VRF, when you're doing your import route target values and your export route target values, you're going to do another export route target value that says export route policy in this route policy here. Same thing as on iOS XE, it's called a export map. So it's the same function, just they just do it differently in iOS XR. So if we look at our VRF here, go run VRF. Let me see if they're gonna, yeah, there we go. So right here, we're saying we are going to not only export routes with this value here, we're going to add this value at the end. Okay. So from a BGP perspective, if you know BGP, VPN v4 unicast, we should see routes here. So routes, well, we're on router 1, so technically R21 is connected to us. R23 is on the other side, and as you can see, it says, hey, this is the next hop, but here's the color right here, color 200, because that was added to the route the same way here on the other side. Right? It was added to the extended community. So when I say, hey, PCE, give me a automated path to get to these colors, and this is the automatic tunneling aspect, because once I export it with the value and I ask my path computation element to give me a path for this color, the PCE is going to say, oh, there's a route that came in with this color. We need to calculate a path so you can get there. So now you don't have to worry about creating a static policy. Kind of saves you, cut down the time on kind of creating these dynamic tunnels. Now this is still constraint SPF, but it saves a bunch of time than creating the actual color, doing the endpoint, creating the policy. It's a pain in the butt if you want to do it manually. Now, if we want to go a little bit more and look at this actual route, 2331. I think we could do detail. Yeah. Let me do this. So BGP, VRF, I think that one. Let's go 10, 255, 255, 23/31. Hopefully I can use detail on that. There we go. So you get a little bit more detail. And here you go. That's what I wanted you to see. So the extended community, you see the color value of 200 was added to it, and then the RT value is obviously 65001. Now, that's basically SRTE in a nutshell with the SDN component involved in it. Now I'm going to show you the policy that was created by the PCE. I didn't create this policy. I just said, hey, give me an on-demand. I did an on-demand tunnel for this color, and I said, PCE, give me the computation to get there. So now to view the policy that was created, you do show run segment routing, traffic engineering policy. I hate when I do that. Policy, let's see, what policy did I call this? Let me look real quick. Okay. Let's see. What do I want to look for here? Do I want to do PCC or do I want to call something else? It's policy. Policy. I believe I called that before I do this, because I usually get this mixed up sometimes, so I have to be careful with these commands here. Graphic engineering, on demand, color, let's see 200. Let's see if I can find that there. Yeah, so that's all there. That's good. I just want to see my policy now. I might be losing my mind on the policy thing. Identify the name of the policy within the map. Does it do? It definitely, that is not it. And that, you know what it is? I should show run. I should did this. This is it. Segment routing. Traffic energy policy. There we go. Hate when I do that. I knew something was up. His policy was wrong. I put run in there instead of showing the actual policy itself. So here is the policy. Now, you see this one is inactive, so we're not really worried about this, right? But this one is what we're worried about. See, this is the preference 100. Higher preference obviously is going to take over. Now, this says BGP on demand, right? So this is that ODN active. It's dynamic. The PCC information, this was created automatically after it got its calculation from the PCE. As you can see, dynamic PCE. So I reached out to PCE 10, 255, 255, 9. Metric was using a TE metric because I didn't use IGP as the metric, so it just defaulted to TE. And as you can see, here's all the, this is the path that was calculated by router 9, not by router 1. It was calculated by router 9. So router 9 is the controller. This is the SDN piece, right? Router 9 is the controller saying, here's your data plane. This is how you're going to get that packet from one place to the other place. And if we look at this from a node standpoint, it is going to go to 31, 33, and if that's adjacency SID, then 19, which is in router 4's lane, and then 36, which is this one here, and then 37, which is this one here, and then router 6, and then pop out. And that's what was calculated by router 9. Obviously, this binding SID is what actually puts it in the routing table and stuff like that. So now, router 1 has its path calculated via router 9. Router 1 did not calculate this itself. It's an on-demand tunnel, like I was telling you. And we are going to try to ping the loop back. So let's look at the table here in BGP to see if we got a route. So we do have a route. It is valid. So we should be able to ping the loop back on 23 without a problem. So if we ping in 255, 255, 23, source from the loop back, boom, worked perfectly fine. Now, technically, like I said before, technically router 6 to router 1, router 6 is going to null 0, but it doesn't matter because the labeling is going to actually dictate how the traffic is going to go. Because someone's going to ask, well, how do you know how to get to router 6 if you're sending it to a black hole? Well, that's just to get the next hop into the routing table. The labeling is what's going to take effect, right? And as you saw at the end, it showed the label for router 6. This is why I'm saying you're kind of hacking it a little bit to get the next hop into the routing table, just so you can get the calculations correct from router 9. And then you know where to go. You're like, okay, I just put this whole label stack on it and forwarded the packet, because we're no longer routing based on IP or routing on labels. This is why you got to know what MPLS is all about, because you're not routing on the IP per se. It's just PE to PE transport, and you're using labeling to get there. So now what we're going to do is we're going to validate. I'm going to pull up router 1 again. I'm on router 1. Slide this over here. And we're going to look at that policy. Now, we're going to do a trace route. Now, we should see all of this going through on that trace route, all these labels. So let's trace route this time. And I didn't turn off IP propagation, so or TTL propagation, so we should see all of this. So the first hop should be router 1. Now look how long that label stack is. Look how long. Now everything now you're gonna see the labels just constantly stripping off. So that label, that service label, literally got 1, 2, 3, 4, 5, 6, 7, 8 labels stacked on top of it. And then the last label is the service label. So the last label is that here. That's the VPN label right there, or technically the service label. But as we move through the network, we are stripping off labels. And it's correlating with this over here, because we're at 37 right now. And then 37 should strip off. We should be at, yep, there we go, 16006. And then it should be the service label. That's the last thing, which is 24007. And then when that gets stripped off, that's, the PHP process just happened. So now that we just got the VPN label, and then that gets popped off, and then it's a regular IP packet, and then it goes to the loop back. But as you can see, the service label did not move. The service label did not change, because that's the label that's shared by BGP, right? That's signaled by BGP. And then when it obviously gets to the ultimate router, the only thing that's left is the VPN label. PHP happened at the router before, which is called the penultimate router. But I really want you to pay attention to here. Look at that. That's the label. Right here is the entire label stack that got pushed on the packet. This is the imposition part. You can put a lot of labels on a service label. It's just not one. Seeing your CCIE studies, you're so used to seeing the transport label and the service label, and that's it. So you only see like 2 labels. When you do this technique, you can see, as you can see, you got 8 labels on here. You can see 8 labels. Ooh, I'm just talking too fast. You can see 8 labels plus the service label. So you can stack, this is the label stack, right? You can stack a bunch of labels on top of that, right? Technically, this 16 one would be the bottom of the, if we want to Wireshark this, the bottom of the stack label will obviously be that, because there's nothing else after this. But yeah, man, that's MPLS SRTE with the SDN component, which is the PCE path computation element. This is a very advanced technique. You're not going to learn this in your CCIE enterprise. This is not an enterprise topic. This is more of a service provider topic. But it's good to know that this actually exists. So when you're taking your CCIE studies for enterprise, you realize, yes, it's a high level. This is why I say it's a high level cert, but it's kind of the beginning, right? It's like the entry level CCIE. Even though it's a hard exam, it's a super hard exam. But when you take it and then you see something like this, you like, oh, I thought I knew MPLS like back of my hand. And then you see something like this, and you're like, I have no idea that you can do this type of stuff in MPLS. At least that's what I got when I start doing stuff like this. I was like, man, I really thought I knew BGP and MPLS like the back of my hand. I didn't even know anything about SRTE. I didn't know about MPLS TE. I didn't even know BGP was a part of labeling. I knew it was part of labeling, but I didn't know that like when we start talking about inter AS VPNs, A, B, C, and D. You have no idea that stuff even exists when you're doing your traditional CCIE route and switch enterprise stuff, right? So that's why I always tell you, don't just study for the CCIE, right? Don't just study to pass that. Study to pass it, and study to know more than just the stuff that's in the curriculum that you need to pass. It's a lot of stuff you need to know, but going past that mark will actually make you a phenomenal engineer, right? Because you're going to run into situations that are not things that you studied, right? So you need to know how protocols work down to the like nitty gritty. If you really want to be an expert, You really got to know this stuff down to the nitty gritty, to the ones and zeros, or I like to say to the matrix code. Um, because stuff like this, you see something like that, you don't want to sit there and be like, I have no idea what that is. But again, keep studying, keep labbing, keep learning. This is Don from Padlock Technologies. I really hope this video was informative. This is something I really like doing because I love the SDN piece to it with the controller part. So I really hope you enjoyed this video. Don't forget to share, comment, like, and subscribe. And if you are looking for help on your next network infrastructure project and you need to bring the big guns in, somebody that has been doing this for almost a little bit more over 20 years now, over 2 decades doing this, right? And, has a skill set in multiple disciplines and you need help, click the link in the description. Let's get a discovery call and start talking to see if I can even help you. I don't know if I can help you unless we get on a call. Hope you enjoyed this video. Thank you and have a nice day.